The radius of convergence of the power series summation running from 0 to infinity 2 raised to the power 2n x n square is. 4 option is given to us and we have to find the radius of convergence. So normally we have the two formulas as we use to find the radius of convergence. Limit un divided by un plus 1 or 1 upon limit un raised to the power 1 upon n. This is ratio method or ratio test we know, and this is root test. We normally use these two methods either to test the series is convergent or not, or find the radius of convergence, because if we know the radius of convergence then we can say about the convergence for which values this series is converge or which for which values this series will not converge. So somehow both are same terminology, and one terminology we use, this is radius of convergence, and sometimes examiner asked about the interval of convergence. Interval of convergence. Interval of convergence sometimes may differ because of the endpoints. Endpoints say we can't say about the convergence. Sometimes series converge, sometimes not. So it is more precise way to say about the convergence when interval of convergence we find. So which one method is appropriate or good for a particular question? It's comes from the practice. When n is coming in the power or exponent, apply root test. Otherwise this one is helpful in most of the cases. When x is, when suppose this is comes out x minus a raised to the power n, then we should to take mod, because of we don't know about the for which values of x this series is converged or not. So we apply ratio test only for positive term series. So use mod or absolute bar. So I'm going to use root test here. Using root test, as this series is given to us summation 2 raised to the power 2n x raised to the power n square, it is not in the form, not of the type summation an x raised to the power n. So put n square equal to m, and then this series can be written as summation 2 raised to the power 2 root m x raised to the power m. Now this is much similar than this form. Now apply root test. Then r equal to 1 upon limit, this is our un, limit 2 raised to the power 2 root m raised to the power 1 upon m, and limit coming from m tends to infinity, and it will be 1 upon limit m tends to infinity 2 raised to the power 2 root m divided by m, and it will be 1 upon limit m tends to infinity 2 raised to the power 1 upon root m, and when m tends to infinity then this term will goes to 0, and 2 raised to the power 0 1 upon 2 raised to the power 0, it means 1 upon 1, hence 1. So radius of convergence r is 1. This means this series is converged only for when x is less than 1. Now option B is true here because 1 is in option B.